Okay, now here's the proof of the last four. The proof of the last four is not nearly as complicated as the first because we have, of the first two, because we have the derivative of sine and we have the derivative of cosine, so we know those. The derivative of sine is cosine, and the derivative of cosine is negative sine. And now, in fact, we know those two, we can do the last four proofs without having to do the whole frickin' limit thingy. Here's what we're gonna do. To do the proof of this one, we're going to say sine over cosine is tangent. So I'm going to rewrite it. We're going to do the same thing for all four of them, right? I'm going to call this the cosine of x, the sine of x, and then, and now hopefully you get what I'm doing here. Well, if I do this, then notice what happens. I can do the proofs way easier, can't I? I can do the proofs way easier, can't I? That's a quotient. All I gotta do is do the quotient rule, right? When I go take the derivative here, right? So all I gotta do is say, oh, I know how to take the derivative of this. It's bottom times the derivative of the top minus the top times the derivative of the bottom. And again, these are the two new ideas that we did in the last video, right? Did I do that right? Bottom, the derivative of sine is top minus the top times the derivative of the bottom. Oh yeah, we're good. I just had a panic attack. I'm being dumb. Sine squared. So cosine times cosine is cosine squared. Sine times sine, a negative times a negative is a positive. Sine squared. Cosine squared. Cosine squared plus sine squared. Now you do have to remember that. You have to, that is something I should have talked about earlier. Sine squared plus cosine squared, or in this case, cosine squared plus sine squared is 1. And that is secant squared. And if you remember from the first video this week, the derivative of tangent is secant squared. And the rest of the proofs are very similar to this one. They're very similar, right? Cotangent is cosine over sine. So what am I doing? I'm doing 4 quotient rules, right? But I do need to know the derivative of sine is cosine. I do need to know the derivative of cosine is negative sine, right? So here, bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Now here, you're going to get sine squared negative cosine squared over sine squared. What you're going to have to do is you have to factor that negative out. So I factor the negative out. And of course, then I still get my 1. And then again, just like we did for the cotangent, we have to know the reciprocal is cosecant. But there's a negative sign on it. And again, this is going back to the first day where I told you that these are the ones you had to know, but here's kind of one. This is a proof of it, assuming that you know sine and cosine. Now, here, a little tricky, you have to know the derivative of 1 is 0, right? So, bottom times the derivative of the top, and that's going to be 0. The derivative of 1 is 0. Sometimes people panic when the fraction has a 1 in it instead of a sine over cosine or something like that. So it's bottom times the derivative of the top minus the top times the derivative of the bottom. And again, this is what you have to know. You have to know the derivative of cosine is negative sine from yesterday over the bottom squared. So notice you get sine x over cosine squared x, which is legitimately the answer. But if you remember, that's not what I said. I said it was secant x tangent x. Notice what I do. I break it up. And everyone does this, so you got to do it. So you get secant x, tangent x. And then last but not least, bottom, again, derivative of the top minus the top, derivative of the bottom, all over the bottom squared. And again, 0 times anything is 0, so I get negative cosine over sine squared. And again, this is legit. There's nothing wrong with that answer. It's just that no one writes it that way. They break it up. And 1 over sine is cosecant, and cosine over sine is cotangent. Okay, those are the 3 videos for the week on the 6 trig functions. In the final analysis, what you really have to know is the 6 trig functions, okay?